things going here. Should get some audio in here now. And this is me doing some further testing on using streaming with Sonic Pi. And in this particular example, I've just got a little live loop which is playing away quite merrily. In fact, there's two live loops, but I'm only using the first one at the moment because I've got a stop command in here when we get down here. And we could perhaps just have a brief look at this and see what it's actually doing. I'm just going to check one thing first to make sure that everything is functioning properly, and that is to go to the output of the stream and just check that it's actually running correctly and I can see it. So let's come down and just have a check out and see, and it looks like live now. Yeah, I'm seeing that and hearing myself twice over, so that's cool. And I'll just put that away and we can proceed. So, welcome to my channel, RBN1Tube, and this little stream which I've entitled Sonic Pi Snippets. And as you may know, if you've been following me either here or on Twitter at RBNman, and also on the Sonic Pi in Thread site, I've recently produced a downloadable deb file which lets you install the latest version of Sonic Pi, which is Sonic Pi 3.2.2, onto a Raspberry Pi. And what you're looking at the moment on my screen, I think, is a picture of Raspberry Pi. And just to prove that, what I'm going to do is to come up here and I'm going to, here we are, I'm going to turn on the preferences and I'm going to change the transparency of the screen here. And you can see that behind Sonic Pi we've got the standard Raspberry Pi desktop screen. And you can also see that I've got jack audio connection kit running. That's because I'm actually using quite a high-class external audio card which can take some nice audio out of there and feed it into my Mac and feed it into this stream. And the reason you're seeing the Sonic Pi is that I'm looking at a copy of the screen using VNC Viewer, and that's therefore the screen appearing on my Mac and therefore being broadcast to you. I'm going to take the transparency down so that we can see things a bit better, and let's get on with the basics of this particular broadcast. As you can see, I've got a live loop which is called Live Loop 1, and that is going from here down to here, and this live loop is using a, in fact there's one extra line in there which I was playing around with I don't actually want. I'm going to take that out. There we are, and we'll just rerun that again. Okay, and what this live loop is doing is that it's using a BPM value which is set by the variable here as 180. This is pretty naughty actually. I'm feeding in external variables into Sonic Pi. Effectively they appear as global because they're created before the live loop runs in the main thread of the program. But this is just an illustrative live loop, as we're going to change it in a moment. But for the moment, that's the easiest way to get the information in and to keep it near the format that I'm going to have the final live loop. I've also got a variable called ch, which is equal to 1. And inside that live loop, I'm using a Ruby statement This is not actually part of the Sonic Pi language, but it's quite convenient to use here, and that is the case statement. And the case statement starts off with a command saying case ch, and it then interrogates the value of that. And if the value of ch is 1, then it's going to do this. It's going to play the BD house sample panned to 0.5 to the right. If it was 2, it would play a tom-tom, and if it was 3, it would play the loop arm end beat stretch. And it's then going to sleep 2 beats, and it's then going to back and start the live loop again. So if I was to change the ch value to 2 and rerun that, then as you can hear, it's going to play a drum tom-tom high, soft, and panned to -5. This is on the left hand side. Perhaps if we change that back again, that should be coming out slightly further to the right. That one is coming out slightly further to the left. And if I change it to 3, it's going to play more or less continuously the loop arm in sample, which has had its beat stretch set to 2, so it will last for 2 beats. It's played a bit louder at an amplitude of 2, and it's going to go more or less continuously because there's a sleep time of 2 in the live loop. So as it ends, it's going to restart. So we'll set that back to 1, stop it, and we can restart again. And the other thing we can do if we want to is to change the metronome setting for this particular live loop. If I put the BPM down to 120, then as you'd expect, everything slows down a little like that. Now, there is a second live loop here, and if I remove the stop command in the middle and scroll up a little bit, you can see that this live loop is going to use the same BPM setting, and it's going to use the same case statement for the value of ch. And when it's 1, it's going to play 2 drum cymbals. When it's 2, it's going to play 2 separate tom-toms, 1 mid and 1 low. And when it's 3, it's going to play a drum splash hard. And what we're going to do is just to play these both together. We'll start off with the channel setting to 1. There you can hear the sample BD house is panned 0.5 to the right, and you look at the drum cymbals, they're panned in the same way. If we go to ch equaling 2 and we rerun this, then we actually get 3 drum tones, one after the other. Drum tone high, tom high, then a tom mid, then a tom low. And if we change it to 3, we get a continuous loop arm in sample, and on the other one we get drum splash hard, and they're actually one on the panned hard left and one panned hard right. If I actually just stop this live loop, let's just put in a stop in it, the easiest way to do it. So I'm going to just put an extra line in there, put stop in and rerun it. So that stops. You can hear, or should be able to hear, if you've got stereo speakers, that the first of the drum samples is on the left and the second one is on the right because of these pan settings. Okay, so that's these 2 simple live loops, and you may say, well, what's the point of that? That's really quite a simple thing. Well, it depends to what extent you've used Sonic Pi already. If you're a beginner, then there's actually quite a lot of new stuff there, the case statement particularly. But you can see the general idea, which is what the live loop does, is it simply goes through all the commands in sequence. When it gets to the end, it goes back again and it starts once more. Although in this case, we actually stopped when we get there. That stops that live loop running. But if I put a hash symbol in there, then that comments that out, and that would run continually again. And we can put just perhaps the stop in there just to get back to running that first live loop by itself. And that was doing it. Let's do it with something slightly more sedate, with back to ch equal to 1. So that's just running that, and all that live loop is actually going to do is it at a fairly sedate rate of 120 beats per minute. It's going to, when it gets here, ch is 1. It's going to play the sample BD house, panned a bit to the left. It's going to ignore all this when 2, when 3, because it isn't. It's then going to sleep 2 and go round the loop again. Now, why have I done this? Well, let's just stop that running, and I'm going to change to a different buffer, and this has got essentially the same live loop. You can see that part of it is the same there, but, or both the live loops are the same there, but there are actually, there's the 2 live loops, they're exactly the same, except that at the beginning of each of the live loops, it's got a command that says ch bpm equals sync, and then there is an OSC call being received. And this OSC call is sent with the message address /B1. We'll come to where it comes from in a minute. Otherwise, that first live loop is exactly the same as the one which was over here in the second buffer. There it is again. The only difference being that we are actually setting or passing in the values of BPM and CH, not externally by setting them there, but by sending an OSC message, and that OSC message is received, and when it's received it causes, if you like, a queue here, and that queue puts the first value of CH, which is going to be sent by the OSC call, into the variable CH, and the second one, BPM, into the variable BPM. And so the live loop will go on exactly the same as before. There is no sleep 1 there because that's going to be dealt with in a slightly different way, but live loop 2 is exactly the same as it was before on this other program over here. There's live loop 2, exactly the same, except instead of having this command here to set the BPM value and picking up the ch command right from the beginning where it was set there, it again is also going to be set by means of a received queue. This time the queue is for an OSC message that is sent to the address /B2. This one was set to the address /B1. So the question is, where do these come from? And the answer we can see, if we go further up, there's quite a lot of extra stuff up at the top of this program. We can forget possibly initially about the use random seed command. That was just there to add a bit of variety, which we'll see later on. And we use one other feature in Sonic Pi, and that is that if you have a section of a program here which you might not want to use, you can actually put it inside a statement that says either comment do and ends there when it gets to the corresponding end, and that's effectively the same as commenting out this entire section. And we could have done that by doing something like this, a command and a sorry, I'll do it in this one, a command and a backslash like this. Let's see, there, like that. That comments them out, but I'll take that off again because that was slightly different. We'll have to do it this way. Just select all of those again, and right up to the top, and we'll uncomment them by doing that. Now what I did there can be done exactly the same way, simply by just changing this line from comment, that's when they all had the hash signs at the beginning, to uncomment, which is what they are now, so that these lines are actually active. And this is where we use one of the features which is new to Sonic Pi, running on a Raspberry Pi, with the advent of version 3.2.1 and 3.2.2. It was in the previous 3.0.1, which ran on the previous Raspbian stretch, which would run a couple of years ago, or nearly, yes, just over 2 years ago, on earlier Raspberry Pis, but would never run on a Raspberry Pi 4. And the Sonic Pi, which is on Raspbian Buster, unfortunately doesn't fully support MIDI or OSC messages. But the two versions which I've released very recently will run on a Raspberry Pi 4. And I'm running the latest version here, which is Sonic Pi 3.2.2. And if we look at the bottom of the screen here, let me just double check this. You will see, or should see down here somewhere, is it on the screen showing? No, where it's because it's not showing because I've got the preferences gone. But if I turn the preferences off, you can see Sonic Pi 3.2.2 and Raspberry Pi 4 gigabytes. That's what this is running on. Okay, so what we're going to do is to use an OSC command. Now, if you're new to this, this is simply a way whereby you can send more or less any information you want in what's called an OSC message. And if you're going to use Sonic Pi to send it, you need to tell Sonic Pi where to send it. Now, in this particular case, I'm going to send the message back to itself by saying use underscore OSC, and then that is the IP address of where I want the OSC message to go. And I've said localhost, which is simply just the address of the machine in which Sonic Pi is running. And the 4560 is the port in which Sonic Pi is set up to listen to incoming OSC messages. And that you can see if you go to the preferences and to the I/O setting tab here. You can see that Sonic Pi has a local IP address of 192.168.1153, and it's listening to incoming OSC messages on port 4560, which is where that comes from. As well as that being its local address for as far as external parts of the network are concerned, the local host address I've used is 127.0.0.1, and that's, if you like, a loopback address, and so Sonic Pi sending back to itself. We're also, a bit later on, going to send it to Sonic Pi running on my Mac. And if I grab the OBS screen for a minute, if I can work out where I've parked it on my screen, here it is. I'm going just for a minute just to change. I've got three screens here. That one is showing just the Raspberry Pi. This one, which I'm going to change to, hopefully, is it changed? Oh, looks like we got a slight problem here. Let me just see if I can. Oh, I know why. I'm using the wrong mouse. This one here is looking at, or should be looking at, I do appear to have changed. Oh no, maybe I do it in a different place. Yes, I do it over here. Do I? I thought I did scene screen transitions down there. Well, we may have to stop and change this in a minute. Let's see. Yep. Oh, hang on. I see what I've done. That's better. Going back again. Ah, hooray, we've got there. That is looking at the screen on my Mac, and if I go down to the bottom, that hopefully is looking at both screens together. Top left, you've got the screen for my Raspberry Pi, and top right, you've got part of the screen for my Mac. I'm going to go back to the Raspberry Pi screen for the moment, and we'll take up back where we got to. Sorry about that little glitch. If you saw my main screen, it's just amazing. There's just so much on it. It's hard to work out what's what. So we'll get rid of the preferences menu, and I'll choose the mouse so that you can actually see the cursor for doing that. So let's turn the preferences off and back over here. So that address 192.168.1.129 is the address on my Mac. Let's just switch back to the Mac a little bit, and if we move this a little bit, can I just move it up there for a little bit? I'm going to make sure that we've got that yeah, over there, and we're going to change to show the preferences on there and the IO preferences, and you can see that the Mac local address, which is down here, is 192.168.1.129, and that it's listening again on 4560, the same port. So we'll just park that out of the way, and I'm going to switch back again to the Raspberry Pi screen. There we are. And I've turned off some of the logging, which is going to just distract us a bit. We might turn it on in a minute. And then we've got a live loop here. And what this is going to do is to, let me just scroll that up a little bit here. There we are. That first live loop is going to let us change the tempo setting. You remember in the first program that we looked at in the other buffer, we had BPM set to a fixed value. Well, in this live loop, it's going to go through a range of values, and that range of values is going to go from 120 to 240 inclusive, and it's going to have step sizes of 10. And if I just make that a little bit smaller and scroll over a bit to the right so that you can see the end of that line, it's going to mirror that. So it's going to go 120, 130, 140, all the way up to 240, and then it's going to go back down 230, 220, 210, 200, all the way back down to 120. And the tick function there is going to change it each time this loop goes round. So that is going to vary the value of our value BPM. And what we're going to do is to send it. We'll ignore this one for the moment. We'll come back to that in a moment. Remember that other address there, 152.153, is actually going to be, in fact, that's the wrong way around. I think I've just loaded this. Yeah, this is running on here. I need to change that. No, sorry. That's going to send it, or should be sent to 129. That is going to send it to my Mac. And this one here that says OSC/BPM is going to send the BPM value to this machine, and then it's going to wait for 1 second, and then it's going to stop. Now what I'm going to do is I'm just going to stop the program immediately after this loop here. Say stop, and I'm going to actually comment that out so that the OSC logging will actually run, and I'm going to run this program, and you can see the OSC messages that it is sending. The first one to address 192.168.1.129, port 4560. It's going to send the OSC message /BPM, and in brackets after that you've got the current value it's sending. You can see it's changing each time it goes round the loop. But at the same time, it's going to send the OSC message to localhost. That's back to this machine, the Raspberry Pi, and it's going to send it to the same address /BPM and the same value. These two values will coincide each time. So we're continuously sending an OSC message with the current BPM value. It's as if we stop that and we go back to the previous screen up here, that we were manually altering this 120, 130, 140, and then continuously running the program each time we do it. So if we ran it like this, that's running to 120. If I now change it to 130 and run it, it gets a bit faster, and we're getting up to about 240, I think, at the end. So by the time we do that, it's really going pretty fast. So that's what's essentially happening in this screen here. This little loop here is simply sending tempo values, and they are separated by 1 beat. Remember, that itself is going to change because we are, in fact, that's going to remain fixed because we're not using the value of BPM in here. So it's always going to be 1 second apart that these actually appear. Now, let's look at the next live loop. And what this one is going to do, if we get rid of that stop command, so that that can come in here, and I'm going to stop the program after this loop so that we're going to get both the first two ones running, both that loop and that loop. In other words, everything which was in this commented section that we discussed a moment or two ago. And this live loop I've called Metro, and I've delayed it by a very small amount of time so that we've got the other loop running before this one runs. And we're going to have set up a tick command which I've called xselect, and this is going to run at a 1/6 of the rate that this particular loop runs. So the value of tick, which is going to be incremented each time this loop goes round, will go 0, 1, 2, 3, 4, 5, and then 6, 7, 8. For the first 6 goes, this will have a value of 0. So 0, take the remainder when you divide it by 6, is going to equal 0. So that will set this tick equal to 0. Next few times it will still equal to 0. It will not equal to 0. But when we get to tick being 6, 6 divided by 6 is 6. The remainder when you divide 6 by 6 is 0. That's made to make that tick increment again. It will become 1. And we're going to choose a value 1, 2, or 3 for the variable x. And what this is going to do, it's going to be analogous to the ch value that we had here. Remember, this had 3 possible values, 1, 2, or 3. If we come back here, we're going to make it slightly more complicated. In fact, I'm not going to say anything about it. I'm going to come back to this. I want to show you it all working first, and then we'll come back to how it actually works. If I start that loop, you can see that we're sending a whole load of OSC messages out to addresses B1 and B2, which you can see down here. If I stop that and we just look at the log, we can see, if I scroll up a little bit into the log, that here we've got an OSC message being sent to the address 1129, which is my MAC, and addressed to BPM, and there it's got 200. That's got 200. This is the one which is sending the BPM value. And then after that, we've got something sent to the address B2, and it's sending two values. It's sending a 3 and it's sending a 210. The 3 is equal to the CH value, and the 210 is going to give us the BPM value. And if we go back a bit further, we can see one here which is sent to the address B1, and that is going to my Mac, and it's sending the value 3 and 210. And then probably a bit further back there is one which is sent to B1, and that is going to have the value W1 and 220. So there's lots of OSC messages being sent to the Mac there. And at other places in the program, here's one where we're sending to localhost, that's this machine, the Raspberry Pi, and it's sending to the address B2, 3 and 230, channel 3, BPM 230. And it's then sending to the local host to address B1, channel 2, 220. And that, we remember, is going to affect these loops here, which are going to run when we actually let it start going. I'm going to take that off there, and I'm going to make sure that my Mac is not running. If I go to the Mac display and I click on the stop button, you can see that if I start it again, you see that start. I get to stop it there, so that's stopped. And then we're going to switch back to the Raspberry Pi one here, and we're going to make sure that that's stopped for the moment. We're going to make sure that that's uncommented, and so we're going to send both to localhost and to the Raspberry Pi, but I'm just going to look at this machine for the moment. Let's start this running. See what happens. And you can see that we've got things happening occasionally. I'm going to turn off the logging, and I think it'll become a bit easier to follow when things happen. Let's just run that again. Now what's happening? Let's stop it there and just have a look. Occasionally it's sending some OSC messages to 129, that's to my Mac, but since I stopped the program running in my Mac, those are ignored. But it is also sending at different times things to the local host, and you can see that if we find one of those locally here, it's sending to localhost B1, the OSC address B1, 3 and 180. And if we look down here, this particular live loop number 1 there is going to react when it gets an OSC message coming in addressed to B1, and it's going to pick out two pieces of information. In the first one, it's going to put into CH, that's the value 3. The second one, it's going to put into BPM, that's the value 180. And it's then going to go through this. And if CH is 3, it's going to play the loop amen beat stretch, and it's going to be doing it with a BPM of 180, in other words, quite fast. So it's going to play that live loop once. When it gets to the other end, it'll stop, because this is like a queue. It's waiting for a queue to come into which it's going to sync, and it'll wait for another message addressed to B1 before it proceeds. And the next time it gets here, the BPM may be different and the CH value may be different, so it'll do something different. It'll play one of these, and it'll play it at a rate specified by the BPM value. Similarly, we will find that there are some addresses which are addressed to B2. And if we look a bit further up, we could probably find one here. Let's see, that's going to be 1. Where's the one that's going to be 2? Here's one going to be 2 to the local host. And in this case, it was going with CH1 and a BPM of 170. So in the second loop, when it gets this, the value of 1 there will be read into the CH value, and the value of 170 will be read into the BPM value, and this would have played the drum cymbal closed twice at the rate given by that. It'll then finish that loop. It doesn't do anything else, and it then goes back and waits for the next cue to be received. And these cues are coming from up here, from this rather complex, let's make the size a bit smaller so hopefully you can see a bit more of the line there. It's going to come from here, and it's going to come whenever we get a, oops, I didn't mean to do that. I've moved up and down. Let's go back to wherever it is. It's up here. It's this one here. I've moved it to the right. I want to go to the left. There we are. And a tiny bit further down so we can see hopefully all of the live loop. Yes, to just fit in there. So X is set to 1, 2, or 3, and it's going to put into a variable 1 either 1 and 2 inside a list, or just the value 1, or just the value 3, or the values 2 and 3, or 2, or 1 and 3. And this is governed by the look X select, which we discussed a little while ago, which is going to go on by 1 every 6 times round this loop. So let's suppose it's the first time round this loop. 1 is going to have the value 1, 2 inside a list. And what's going to happen is we're going to get the current value of the BPM from the very first loop at the top. Remember, that was changing the BPM value each time it went round that loop from about 120 up to 240 and then back down again. It's going to print that on the screen, and if we look further up the output, or further down the output, we could see one of those print statements. Here's one here. Print BPM, the value of BPM. It's then going to print the value of X, and it's going to print the value of the 1 variable. In this case, 1 variable is just got the value 1 in it. So it comes on to the next line, and it says if 1, that's the list which has just got a 1 in it, includes the value of X. Well, in this case, X is the value 1, and that 1 list does include the value 1. So what it's going to do is it's going to put playing locally, which it does there, and it's playing locally with CH equal to 1. If it isn't that, it's going to play remotely. Now, all the locally play things are going to send OSC messages addressed to the local host, which is just the default one. If it comes up with playing remotely, it's going to send to the remote address. That's the 192.168.1.129, in other words, my MAC. In both cases, it's going to send to the address B1, and it's going to send the current value of X, which is 1, and the current value of the BPM, which was 170 in this case. And there you can see the OSC message it did send. It sent to localhost port 4560, address B1, the values of 1 and 170. And what will happen is that that will send to that address. It will be picked up by the live loop below, and it will play that. So that's how that works. If we take a different value, and if we come up a bit further, we can see, let's see, here's one. When it got to BPM 150 and X was 3, X was 3, 1 was still that list just 1. So when it got here and it says if 1, which is just a list containing 1, includes 3, well, it doesn't. So instead of putting playing locally, it's going to put playing remotely the value of X, which was 3. And in that case, excuse my cough, as I said before we get worried, this is just gastric reflux that causes it to me, not COVID-19. When it gets here, it's going to play, it's going to send to OSC remote the value B1. It's going to send 3 and the BPM value. And then it's going to send, when it gets down here to yeah, that's right. That's what it's going to send. It's going to send to this one, to B2, the value of X as well. And we should see that a little further on in the log. There we are, OSC to address B2, the value of 3 and 150. Now, you're probably totally bamboozled with that, but I think the time has come to switch in a moment to my Mac, and just going to make sure that, well, let's just look at the Mac screen first of all. And here it's got exactly the same program as we have on the other side. At least it will have when I switch to the right address. There we are, exactly the same program. But what I'm going to do is to say uncomment on this one, because I don't want this first section to apply. We're simply going to use the Mac to receive messages OSC B1 and OSC B2, and this will enable it to respond to those messages coming in. And if we start this running, which I'll do now like that, and you could see that it's still receiving those because this is still running here. I'm just going to stop that running there, and then we're going to start it again. I'm using the wrong mouse here to do this. Let me just stop that. That's right. There we go. Stop. Go and stop. What's happening? Why have I got two things happening? There's stuff happening there coming from... it's coming from 129. I haven't got the program set up right. Now let's stop this here. Stop this here. I said uncomment. I meant to say comment. I'm getting my comments and uncomments, but I don't want the Mac to send stuff. So I've got that stopped. And you'll notice that in the case of the Mac, the remote address is 153, which is the address of my Raspberry Pi. But I'm not using that. I've got that uncommented. And just to prove that we're treating both the machines correctly, I'm going to put them both on at the same time, which should be that display. And we'll make sure that both things are stopped. So there's a stop on there, and here is a stop on the Mac. And then I'm going to start the Mac running, and it's not doing anything because it's sitting there waiting for cues to come in from the OSC B1 being received and the OSC B2 being received, and they are going to be received from the Raspberry Pi, which we're going to start running now. And if we keep our fingers crossed, then hopefully this should all spring to life. Now what I want to do is to actually just change the max screen so that you can see this across the top, probably there, and that'll make it clear when the Mac is actually doing something. That's actually working very well. Let's see. Let me come across to the screen here and see if we can just move it across a little bit. Down a bit, there we are. You could see both screens, and you could see from the visualizers when each one is receiving. And you're seeing either one is playing or the other. I think we're not actually getting all of the audio from both. So you see they're both playing together, either one is playing or the other one is playing, and they are synchronized together by means of the OSC pulses going from one to the other. So as one stops, the other one takes over. And it works equally either way round. If I come up here and I stop the Raspberry Pi, the Mac stops as well because it's not receiving any cues. I'm going to move over to the Mac and I'm going to stop it as well with its own keyboard there. And then we're going to come up here and I'm going to change this to uncomment. And I'm going to come back to the Raspberry Pi and I'm going to change that to comment. Oops, I've done the wrong one. That one to uncomment, and this one to comment. So if we stop that and start this playing now, then the Raspberry Pi is running, but it's simply waiting because the first part of the program is commented out, and it's only going to be the two live loops down the bottom which are going to receive things, and they are going to receive things from the Mac over here, which I'll start playing. And hopefully they are both working now, and we could switch and just show you one screen at a time. There's the Mac screen. And here is the Raspberry Pi screen. You can hear both playing, but you can only see, obviously, when the Raspberry Pi is playing there. And then if we put both screens on, you can see them both playing, and one of them is, or the other is playing all the time. Now if we stop the Mac playing, that will stop everything playing, and that effectively is the end of that demonstration. Now there's a lot to take in there, and I've perhaps not explained it all as well as I might, particularly the logic inside the metro loop, but I will post this on my gist and put a link below this video shortly, and then you'll be able to go and try it out for yourself. You can obviously you need two machines if you want to make it work best, but at least you can try out each, and it is possible just to send all of the messages to one machine rather than sending them to both, so you can actually get the whole thing working just on one machine. I didn't plan to do this, but I'll see if I can work out just what's necessary to do that. Let's see. It'll be in the this loop here, and if we get rid of the in fact, if we just come down here and we'll just say if true there, and that will always be true, and therefore it's always going to put playing locally. It's always going to send to it locally regardless of everything else. So everything is going to go just to the first machine here, and if I uncomment that and then run this, then hopefully you can see that everything is now going to the Raspberry Pi. Nothing has been sent to the external machine. So by doing that, by simply changing that line, you can force everything to go just to the first machine, instead of using the logic which I've got here that sends some of it to the one machine and the rest to the other machine. And that's how we get that sort of communal playing between the two machines together. But if you do have a Raspberry Pi and perhaps another machine, a Mac or a Windows PC, that you could run the same program on, then just one other thing. If you want to get the best results, it's best if you have both machines connected or hardwired to the same network rather than using wireless connections. You can probably get away with one of them being wireless, but the other one connected to your router hub directly. But you will get the best results if all the machines that you use are hardwired onto the same network. So at any rate, we'll stop that, and thank you very much for running. I would appreciate any comments you might like to add later on. I didn't publicize this particular live streaming because I'm still very much setting this up, but hopefully you'll maybe come across it, and I will publicize that the final video is online. So thank you very much for watching, and if I can work out where the control is, yes, down here, I will end streaming now. Cheerio.